Hello, everyone. It's wonderful to have you all join us today. We're here because today in the world, like always, it's changing very fast. And one of those areas of change are the requirements for manufacturers to address, design, document, so on and so forth for sustainability. We won't get into scope 1, 2, or 3 reduction today, but if you're a manufacturer, especially if you're one that produces products for the EU, you are looking for ways to reduce the impact of CSRD and other regulations on your business. And reducing material input and waste is one of the first steps. And that starts with design decisions and how your design moves through its life cycle. Today, we continue our three-part series covering the ways your company can employ modern tools to tackle your sustainability initiatives in design through modular design, part reuse, and the like. My name is Anthony Byrell. I'm the marketing director here at EAC Product Development Solutions. And today we're presenting sustainability regarding minimizing material waste, presented by one of our application engineers, Stephen Prawley. There he is. A little housekeeping before we begin, though. If you have any questions during the presentation, please don't hesitate to drop them into the chat, and we'll make sure they get answered either during the webinar or after the webinar, but we'll have some time for questions to be brought up. So please, if you have anything that comes to mind, just drop it in the chat for us. We'll also be recording today's session, so pending any technical difficulties, or barring any technical difficulties, we'll be sending out a replay of the webinar following today's session. All right. I'm going to start off by giving a short introduction of EAC for those who may not know who we are, and then I'll pass things over to Stephen. So Stephen, let's roll forward. EAC Product Development Solutions has a mission to help companies transform the way they design, manufacture, connect to, and service their products. Our products, solutions, and services span the complete product development lifecycle, everything from computer-aided design, simulation, additive manufacturing, product, service, and application lifecycle management, or PLM, SLM, or ALM if you're into acronyms, technical publications, IoT, and augmented reality. We've been a leading premier PTC partner, offering the entire PTC portfolio, as well as a leading global solution provider for over 20 years. We also partner with Formlabs and Intamsys to offer 3D printers to address your additive manufacturing needs. So from start to finish, we're here to help you through your digital thread journey, sustainability journey, and modern product development journeys. We offer multiple service offerings to help manufacturers achieve their business goals with a focus on process optimization and the digital thread, as I just mentioned. This includes business assessments, training, migrations, extensive technical support, engineering and design services, and much, much more. We're headquartered in Minneapolis, Minnesota. As you can see, I'm in one of our offices here, with employees spread all across the United States. So wherever you are in the US, we're within reach and ready to help, no matter where your business is located. Now, that was just a little bit about EAC. I'm going to hand things over to Stephen to talk about the more important things of today's webinar. Take it away, Stephen.
All right, thanks, Anthony. And hello, everyone, and thank you all for joining us today for the second part of our sustainability webinar series. My name is Stephen Prawley, and I'm an applications engineer for EAC, and I'll be walking us through the rest of the webinar today. So for our agenda for today, we're going to be looking at an overview of sustainability, talking a little bit about waste reduction, and then we'll get right into some of the PTC tools that can help with waste reduction in specific. We'll kind of be jumping back and forth between presentations and pocket demonstrations to give you guys a good idea of how these solutions work and how they can help with your sustainability goals. Like Anthony said, if you guys have any questions, please feel free to enter those into the chat. We'll address those at the end, or we'll have an open Q&A session at the end as well. As we know, discrete manufacturing must change fast if we want to serve our needs without sacrificing the needs of future generations. And because of this, industry today is pushing for a more sustainable process for companies around the world. At first glance, improving product sustainability may seem costly or risky, but the truth is that this is a huge opportunity for us. We've learned from our customers and our own science-based programs that sustainability has far more upside than downside in our companies. In our world today, there is a certain problem in the way that manufacturing companies are handling materials, in the way that they're consuming energy and handling waste. Our demand for material is exceeding the Earth's capacity. More than half of global energy consumption comes from the manufacturing and production sectors. And right now, only a small percentage of that waste and scrap is actually being recycled. However, all of these problems are certainly worth solving. The majority of companies today are getting on board with more sustainable purchases. Employees today are looking for jobs that have strong environmental goals. And companies with environmental programs in place are seeing an increase in shareholder value as well as proven revenue increases year over year. Now, what most companies and most people don't understand is that 80% of a product's environmental footprint is determined by design decisions. So in the design phase of our product development process, footprints such as emissions, hazardous material, landfill waste, they can all be addressed earlier on in the product development process. Now, before we start, I did want to highlight one of our case studies from one of our customers, Vernig Attachments. So Vernig's exponential growth over the last decade has led to the onboarding of more and more employees, which has introduced new challenges in organizing some of their critical work documents. The inefficiency of finding these documents began to hinder their productivity. So to address this, they worked with us, and we helped to implement PTC Windchill, our PLM system, that allowed Vernig to go paperless. This solution added over 325 productive hours per year by eliminating time wasted on sorting through binders and significantly reduced their paper usage and waste, enhancing both their organizational efficiency and their environmental sustainability. And while utilizing Windchill and putting these processes in place, more than likely they were able to hit some of those sustainability goals of reducing waste, of getting better at processes like recycling, rework, disassembly, so on and so forth. So for the rest of the webinar, we'll be focusing on some PTC tools that help with sustainability, specifically with waste reduction. Today, I'll be going through some of the benefits of Windchill, Creo Advanced Assembly, and Creo GDT Advisor, and how they can help reduce waste for a more sustainable product development process. So starting with Windchill, as we saw in the Vernig case study, one of the best ways of digitizing manual paper processes is by implementing Windchill. So Windchill helps companies to manage product data and processes. It allows users to store, organize, and access documents digitally, enabling efficient collaboration, version control, and change management. Windchill helps to streamline workflows, reduce paper usage, and improve overall productivity by bringing all product-related information into a centralized digital space. So with that being said, we're going to jump over to Windchill and show you some of the capabilities that help with sustainability. Okay, so right now I'm looking at one of the part structures in this Windchill environment here. And it's actually a seat isolator for a zero-turn mower. And just by opening up the information page, we can see a few different tabs up here at the top that kind of contain all of the metadata for this specific part structure. So here we can see some attributes associated with this. If we actually go over to the structure, we can see a list or a parts list, kind of a bill of material, but also we can see all of the parts and the assembly over here in the visualization window. Now we have the ability of kind of interrogating this and rotating it around. As we pick on different parts in here, they'll highlight in our bill of material. And as we pick on different items in the parts list, they'll actually highlight visually for us over here. There's a few different things that we can do with this. Now, with this seat isolator assembly here, we also have other information located in these tabs. So we can see any related objects that have to do with this part. We can see any CAD or dynamic documents. For example, we have some MathCAD calculations attached in here. We can see any changes this is associated to, so change management items. And we can see the full product history of what was done and what was changed to this product throughout its life cycle. We can also see where this is used. So if this is used in any other assemblies or top level assemblies throughout the system, Windchill gives us really good visibility into what those connections are. So with this ability to kind of bring in all of this metadata and how configurable Windchill actually is, we have the ability of actually configuring some of these different tabs up here. And certainly we can configure one for sustainability. So some of the things that I might think would be in the sustainability tab would maybe be the material, how much is used, maybe some process documents about recycling, about disassembly, things like that. We certainly have the ability to bring all of that metadata into one single place so we can access that and start driving towards some of those sustainable goals. Now, I did want to highlight that in this structure tab here, if we actually highlight all of the parts and we go to show all, it'll bring up information about every single part inside of this bill of material, sort of turning this bill of material into a bill of information for us. So in here, we can see we have CAD documents, we have calculations, we have drawings, CAD parts. Anything that we may want to see is available right from this single page for all of these parts that are in this assembly. Now, one great thing about Windchill is that we're digitizing processes. We're taking away from the manual paper processes of the past, and we're kind of putting it all in one place. So let's say I was, maybe a design engineer, and I wanted to make a markup on this part here, right? Without Windchill, we'd have to probably print out an engineering drawing. We'd have to mark it up by hand and then hand it to the appropriate person. Now with Windchill, we have the ability to do that digitally. So I'm going to go ahead and open this up in Creo View. And Creo View is a free lightweight viewer that comes with Windchill with every license. And really what it does is it gives us the ability to interrogate this part a little bit deeper without actually needing the native authoring application. So we don't need Creo to actually look at this part. Creo View will also work with any documents that you may have that are published in the system. It's just a viewable tool that we can attach different things. We can investigate this part. We can take measurements, and we can create digital annotations. So in here, again, we have the ability to look at this part in here. We can, of course, rotate this guy around to get a better look of what it actually looks like. We can do things like transform this. So if I wanted to maybe make an exploded view of this to get a better idea of what these parts individually look like, I have that ability as well. There's a ton of different markup tools that we can leverage in here. So let's say for this part up here, I wanted to maybe take the diameter measurement of this. I could go ahead and click diameter, and then it spits out that diameter measurement for us. Well, let's say I also wanted to quickly calculate the mass properties of a certain material or a certain part in this structure. Something that is very important in terms of sustainability and something that we can easily do with Creo View. So if I just take this mass properties icon here, click on it, click on my part that I'm interested in, you can see that it quickly calculates the mass properties for us. It kind of dives into that metadata and brings that information to us. So we don't have to be engineers. We don't have to use Creo to actually look at some of the items for sustainability in here. Now, the best part about this is we can actually save these annotations against this part within the system so that they're visible to our teammates or to our coworkers. So why don't I go ahead and do that? I'll go ahead and obtain these measurements. And from here, I can save an annotation set. And we'll just name this markup. So now that annotation is actually saved to this part here. If I go back to Windchill and go to visualization, we can see that located here, right? So just a different way of kind of digitizing these processes, making them available to everyone in a more efficient way. So Windchill will help digitize previously manual processes, enabling companies to access metadata related to sustainability. This includes information on materials, recycling or disassembly instructions, and regulatory submissions for different countries. By digitizing these processes, Windchill also reduces paper waste, allowing users to digitally mark up parts using Creo View, which we just saw. All right, moving on to our next one here. There are numerous different modules that we can actually plug in and add on to Windchill, and one of which is the Platforms and Variants module. So this add-on helps create modular and more sustainable products. It helps companies improve their assembly recoverability and reuse after product retirement. It also helps with increasing recycling rates and reducing parts and tooling. So let's go ahead and check out the second pocket demo for us here, talking about Windchill platforms and variants. All right, so here we are looking at another information page. This time it's for a bit more complex of an assembly in this snowmobile over here, this Polaris snowmobile. And you'll see that some of the icons look a little bit different here on the left. And I'm going to go ahead and expand this by 3 levels for us. And in this structure, you can see it's based and made up out of nodes and variants. So with the platforms and variants option that we have in Windchill, we have the ability to create different variants for different sections or different sub-assemblies of this final product, right? So if we look in here, we look at our rear suspension module, we can see that we have 2 different variants or 2 different options in here for that. If we look at our engine module, you can see that we have 4 different variants or options that we can choose from. So kind of setting this up in Windchill and using this module helps to create a very flexible and modular design, right? We can detach parts, attach parts, giving us a really good idea of what's possible and quickly being able to design different types of snowmobiles, in this case, for different applications. So if I actually go up to one of my saved filters, and this is where we can actually choose some of these options or variants that are laid out in the structure. And I click on 600 Indy here. What Windchill will do is it will go through, it will pick all of these different variants that we assign to this 600 Indy version snowmobile. So now you can see that there's 1 option chosen for each one of these nodes here. And it spits out our final product in this type of snowmobile over here, right? So with this, we have a very modular way of designing things, kind of with this overloaded assembly type technique. Now, how do we get there? How do we actually create these options, these different variants? So that can be done under the product context, under option pool. You can see that we have the ability to create new different options. So for example, our engine, our front suspension, we can create them here. We can also create different rules. So let's say we wanted to create a conditional rule where if we have a windshield that is the mid-smoke windshield, we must have the mountain bar and handguards, right? So we can create rules to make sure that we are creating the correct final assembly based on our manufacturing capabilities. We also have include rules, exclude rules, enable rules, and so on and so forth. So overall, Windchill platforms and variants enables us to create modular designs, allowing us to easily attach and detach different components from the snowmobile. This makes it simpler to disassemble, reassemble, and recycle parts as needed. So with this module, we can gain a clearer understanding of end-of-life breakdown, restocking assemblies as spares, refurbishing assemblies for new products, and separating recyclable materials, ultimately minimizing waste as much as possible. All right, another module for Windchill that we can plug in that helps with waste reduction is what is called the Windchill parts classification. So this module helps companies find and use existing parts for new products. It reduces part design, sourcing, manufacturing, as well as improves usability of existing parts and part assemblies. So let's take a look at what parts classification looks like in Windchill here. So on the Windchill homepage, if we actually go over to search, if we have this module turned on, we'll be able to see that we have this classification explorer option here. And this is what our parts classification is. So we have the ability of choosing our different classifications. So right now I'm in the part classification. We can also do this with documents as well. So switching back and forth between document and part classifications. Now in here, you can see that within our parts, we have several different types that we can choose from. And basically what this does is it brings all of these parts together and creates a catalog for our designers. So let's say in this case, I'm a designer, I'm looking for a rivet here. So I'm going to choose in our mechanical parts, I can choose the rivet link. It'll bring up pictures that I can choose from in terms of what kind of rivet I'm looking for. And let's say I'm looking for a solid rivet here. Now in here, it'll bring up all of the results of all of the rivets that we currently have and use in our company. And from there, I can further refine these results. So I can refine them based on type, based on material, based on diameter, for material thickness, length, and sourcing status. So let's say I wanted to look at a stainless steel rivet here, and it brings up my only option for that, right? So as we look at the information for this, again, we can look at the details, the structure, the related objects. We can also see where this is exactly used, and this is pretty important for these classification parts or these shared parts, and being able to directly see, where is this rivet being used in what different products, how many quantities, things like that. Right from here, we can also see how this is sourced and is this sourcing status approved. So for the Americas, the ASME fasteners is our manufacturer and it is approved for Americas. But if we change our sourcing context, we can see that it may not be approved, or we say do not use for the Asia Pacific. So maybe we need to look at different vendors for different markets or different countries in which we are manufacturing. So by using Windchill parts classification, designers can access a shared parts catalog, allowing them to quickly find and utilize in-house parts and materials for new designs. This in turn reduces material waste, it saves time, it lowers costs during the design process. So along with Windchill, Creo 3D modeling also offers opportunities for waste reduction. So advanced assembly is another add-on module for Creo that improves how we design and assemble products. It helps plan and optimize assemblies from the start with top-down design. This module also allows for different teams to work together at the same time on various different parts of a project or a product. It also offers detailed instructions for assembling and disassembling products, making it easier to reuse, easier to recycle, which again supports our sustainability movement. So let's go ahead and look at our next pocket demo for advanced assembly. All right, and as I bring up the screen, you can see we have a assembly here of a zero-turn lawnmower. And you can kind of see that there's some surfaces in here that kind of look a little funky, but that is because we are using a skeleton model to sort of build the geometry of this assembly for us. So if I open up that skeleton model, you can see that it consists of different surfaces, different curves that basically lay down the foundation for our product. So if you can imagine, if we have, maybe a team working on the deck, or a team working on the mainframe, a team working on the drive system, right? All of these things have to fit together, and utilizing top-down design, utilizing um, Creo Advanced Assembly helps make that a lot more efficient, a lot easier to make sure that when everything's said and done, all of our subassemblies fit together and they have proper form, fit, and function for the application that they need. Now, along with this, and actually I can look into this a little deeper and show you how the mainframe was assembled to this skeleton model, right? If we close this out, we can also see maybe the drive system here. So you can see that as these are designed, they're utilizing the skeleton model. They're actually being assembled directly to that. So that when all of these different sections or all of these different teams are done with their work, they know that the product will come together, that it will maintain its fit, form, and function. So the second part to advanced assembly that helps with sustainability is the ability to create process illustrations and process documents. So here I have the deck portion of the lawnmower here. And what I did was I opened up a process assembly. Now in these process assemblies, only available if you have advanced assembly, we have the ability to create different steps, different operations, different illustrations for actually defining processes. In this case, it will be for assembling this lawnmower. And of course, we can do this for recycle. We can do this for disassembly as well. But let's just go ahead and play the different steps that were set up here. So here you can see we're creating exploded views. We're creating illustrations, representations that can be used down the line for the actual assembly of this mower deck here. So by utilizing this process assembly, we can actually create a process document from this, or a process drawing. And here we can see the process drawing. We can see we're bringing in some of those different representations that we created by using that other process assembly. We can change the look, change the actual view of how these look. For example, we're using a wireframe here to show it a little better. We can label the bill of materials of this, giving our shop floor guys a really good idea of how this actually goes together, just by utilizing the CAD model itself, right? So by using advanced assembly in designing complex assemblies allows for effective collaboration, which in turn helps reduce scrap and rework on the shop floor. The ability to quickly utilize CAD geometry within process documents allows efficient creation of disassembly, reassembly, and recycling processes. All right, you guys. So we have one more pocket demonstration for you guys for waste reduction. And this one is Creo GDT Advisor. So what this module does is it helps designers by applying geometric dimensioning and tolerancing to their models. It ensures that these dimensions and tolerances are accurate and that they meet industry standards. By using this module, designers and engineers can reduce errors and improve the quality of their designs. This leads to less material waste and fewer manufacturing mistakes, which helps with sustainability by saving resources and reducing the need for rework again. So let's take a look at one example of GDT Advisor and how it works. And GDT Advisor actually ties in very closely to model-based definition. So if you're not familiar with model-based definition, it's basically the idea of getting rid of our 2D prints and containing all of the product and manufacturing information in the 3D model. So here we'll walk through in one example of how that may look according to the ASME standard. So here we have a part, and you can see that we have different tabs down here at the bottom. These different tabs will show different information related to this part. So on this first one, we can see we have some company information. We have an ITAR notice. and we have some more corporation proprietary information warnings here. So some of this stuff we might see on the front page of a print, for example. Next, we can see the kind of the sitemap. So what this does is it lays out these different tabs that we're going to see and kind of shows us what we are going to be looking at. So right now we're on the sitemap. We can look at titles, properties, notes, datums, and then all of these different features are laid out in different tabs as well. So defining those features, and that's what we're going to be using GD&T Advisor for. So if I scroll through here quickly, we can see some more of the things we might see on the front page of a print: design signatures, material information, notes, datums, and then we get into our actual features. So these are the annotations for our base holes here. We can also see them for our backside holes, our clevis slot, clevis holes, and our counterbore holes on the top here. So before this demonstration, I actually created this annotation right here. And what we're going to do before we get into GD&T Advisor is we're going to create a geometric tolerance for this guy. So you can see I can do that really easily within the 3D modeling space. And now if I wanted to actually edit this, I could go ahead and do that. So I'll go ahead and just change this geometric symbol to perpendicularity. Everything else will leave the same here. So the nice thing about GD&T Advisor, and we can find that in our applications over here. So I'll jump into GD&T Advisor. The nice thing about GD&T Advisor is that we can create geometric tolerances from it, but it'll also go ahead and analyze all of the annotations that we currently have and tell us if it's done correctly or done by the standard. So to walk you guys through kind of what this looks like here, we have in GDT Advisor, we have a feature tree that lays out all of the different annotations and the different features that we have currently set up in this model. And then down here, we have what's called our advisor tree. Now, our advisor tree is going to give us a list of different notices. So any notice that we see that this little I symbol is going to be just an informational notice. Don't have to worry about it too much. Any that have this yellow triangle are going to be warning messages. So they're not exactly errors, but there's something that we probably want to fix in there. And then anything with this red stop sign is going to be error messages. So things that are directly wrong according to the ASME Y14 standard. So let's address some of these errors down here. And we can see this one down here says that a 0 value tolerance is not allowed for this dimension that I just created. Now, at any time, if we wanted to get more information about any one of these notices down here, we could right click and click on more help, and it'll kind of walk us through, according to the ASME standard, why a 0 value tolerance is not allowed, or why, information for these other notices that we see. So in here, it says we need a non-zero value tolerance, and it gives us the step of actually how to do that in here. So I'll go ahead and just choose this guy, give him a tolerance. Then we can click update, and you can see that warning or that error message actually goes away. Now let's address this next error down here that we see, and it says the specified geometric symbol that we chose for this geometric tolerance is not allowed. So if we wanted to get more information, of course, we can hit more help. And of course, it will run through why this is not allowed and how to go ahead and actually fix this inside of the GD&T Advisor application. So what I'm going to do is go over to this pattern. I'll click edit. And it'll bring up sort of this wizard user interface for us that'll walk us through the creation of this geometric tolerance. Now, as I drop down my options for the different symbols, we can see that according to the ASME standard, it'll populate some of the symbols that are correct in this case. And you can see that even if I wanted to choose perpendicularity, according to the ASME standard, it just doesn't make sense. So it doesn't even allow us to choose that. Actually, the only one that it allows us to do is this position tolerance. Now, sometimes we have more than one that are available for us, and it'll give the most constraining option in kind of this green color. But because this is our only option, we can go ahead and click on that position. It'll change that for us. And as we click OK, it'll go ahead and update that for us. Now, I'm not sure if you'll notice, but before we had um, just this 15.88, we didn't have the 4x, and GD&T Advisor went ahead and added that 4x because this dimension is actually referencing these four different top holes here. So it's pretty smart. It'll work well and make sure that um, your geometric tolerances are done correctly and that your part is properly constrained. All right, so utilizing MBD, first of all, can overall reduce the amount of paper that you're using for product definitions. And GD&T Advisor can help ensure that parts and assemblies are defined correctly, which will, again, common theme, reduce errors, reduce scrap, and reduce rework during production. All right, you guys, that is actually all I had in terms of content for sustainability and some tools that help with waste reduction. So with that, I'll hand it over to Anthony and see if we had any questions in here.
Excellent. Thank you, Stephen. I didn't see any questions in the queue, but this was a great set of demonstrations. Kind of circling back to the reason why we're showing these tools. I know sometimes a little bit of the message can get lost when we're showing products, and products isn't sustainability. But being able to manage how teams work together to keep one part, 10 parts, 1,000 parts out of the waste bin is affecting a company's sustainability footprint. It is affecting how much material needs to be purchased or recycled or thrown out, making sure that tolerance stack ups aren't going to make the last part in an assembly not fit and have to chuck it all out. That's a big piece of sustainability, making sure teams are working together and all the different sub assemblies and areas in an organization are kind of coming together and working on common models with similar constraints so that when things get out to the shop floor and people start cutting metal and molding plastic, that everyone knows their parts are actually going to work and not get thrown out as scrap or have to rework and remill, remachine. These are all the little things that kind of roll back to a company's purchasing group and the amount of material that they have to buy and bring into their company and into their production process and eventually report on as kind of a carbon footprint input. So, all of the things that were shown today are excellent, great ways to make sure that the teams are collaborating effectively. Everybody's working towards a common goal and a common design, following standards for tolerancing to make sure that products are designed efficiently, ready for disassembly, ready for remanufacture, little scrap, and we get out the door with a great product and a lower sustainability footprint.